Welcome back to the Fluid Mechanics course. You are now listening to the video lecture on the concept continuum. To understand this concept, the prerequisite concept needed is density. Let us quickly review the cognitive map we generated for that concept. Looking at this cognitive map, you must be able to identify how density is related to mass and volume. Density is mass of fluid per unit volume. A more accurate representation of density is discussed next. The density, at a given location of a fluid, is the ratio of a differential mass of fluid to a differential volume that occupies around that location. The differential volume must be close to a limit 10 to the power minus 9 mm³. If the sample size is less than this limit, the microscopic uncertainty will affect your density measurement. The density defined at a location in a fluid in such a manner will be a function of space variables and time. The density can be varied from one location to another as well as with time. Consider an example. The air density is 1.2 kg per meter cube above sea level. This means that we consider a sample of air near sea level, and the sample volume we considered is sufficiently higher to neglect molecular uncertainties on measurement. Now imagine that we are measuring the air density at an elevated location too in a similar manner, as 1.1 kg per meter cube. If we measure density at several heights, we will see that it varies with the distance from the Earth's surface, in a smooth and continuous manner. This smooth variation in fluid density is made possible because we treated matter as a continuous medium, neglecting its discrete molecular structure. In this assumption, fluid is considered as continuous distribution of matter called a continuum. The continuum hypothesis treats matter as a continuous medium and neglects its discrete molecular structure. Therefore, the property density, or any intensive fluid property, can vary continuously from one point to another point in a fluid. In general, the continuum or macroscopic approach to be valid, the size of the flow system must be much larger than the mean free path of the molecules. This is approximately 5 × 10 to the power minus 8 meters for standard atmosphere. Thank you for listening.